Hello everyone. In this video, we will be solving number of zero-filled subarray. That is today's daily LeetCode challenge problem. So we are given a nums array. We have to return the number of subarrays filled with zero. A subarray is a contiguous, non-empty sequence of elements within the array. So, for example, here. So this contiguous elements 1, 3, 0 is a subarray, and 1, 3, and 2, this is not a subarray. These are like uh, 1, 3 is a subarray, but 1, 3, 0 is also a subarray. 1, 3, 2 is not a subarray because they are not contiguous. Yeah, contiguous means we have to keep all the elements in mm, uh, within the elements should be next to each other. Okay, so in this case, in this example, what is the result output is like we have four ones, four zeros. So 1 0, 2 0, and 3 0, 4 0. These all four zeros will make up for this number. And next, we have two occurrences of two zeros two times. So this is one time and another time is here. So totally like two. If we add it up, then we get six. Now this could be solved with a naive solution, like you keep two for loops, start from I and j, and start if I to j all are zeros or not, and just count the subarrays. But the problem with that is, since we keep two for loops and we will be running from, I will be running from 0 to n and n minus 1, you can say, and j will be also running from 0 to n minus 1. What happens is now uh, this will result in order of n square order of n square as the time complexity. Since the order of n square, which is not a desired time complexity, we order of n square, which is not the time desired time complexity, we because here the length is 10 power 5 and n square means 10 power 10 will be getting, which is greater than 10 to the power of 8, where we can get the time limit exceeded error for this problem. Okay, so how to go about it? So for this kind of problems, these are mainly variable length sliding windows. What we do is we take left pointer and right pointer and count the number of subarrays. So for example, here 1, 3, 0, 0, 2, 0, 0, 4. Okay, so now we will take both the left pointer and right pointer to this. Since these two are 0, we will move both the left pointer and right pointer at the same time. Left pointer and right pointer we will move the same. Since this is also not 0, we will move again left pointer and right pointer. Since it is 0, what we will do is we will only move towards the right side and we will add up the numbers. So next what we will do is next we will move the right pointer here. The right pointer we will move it here until we get right pointer not equal to 0. Okay, since we now we will have a result variable. Since at the previous stage, what happened was both were pointing it to 0, right? So we will update our result variable. Result variable we will update with r minus l plus 1. Why r minus l plus 1? We at this point we see this as a single element subarray. So that's why r minus l plus 1 will make this is the index will be 2. 2 minus 2 plus 1, this will be 1, uh, one element, one length subarray. Okay, so again we will be moving towards here. So what happens is again r minus l plus 2 will wait a minute. Be moving the r pointer to here. So what happens is now the length, the result value, which is our r minus l plus 2 value. Here the index will be 3. 3 minus 2 plus 1, which is equal to 2. Now we are adding to result 2, which earlier was 1. Now we are adding result to 2. Now, why we are adding 2 and how does it account to the subarray? So what happens is in this logic, we will add it. First, we'll add this element. Next, when we move to this, there are two subarrays that we have to consider. The one subarray which we have already considered, we have to consider now this subarray. I'll change the color. We have to consider this subarray, okay, and also we have to consider this subarray. Okay, so subarray from 2 to 3 we have to consider, and subarray with starting with 3 and ending with 3 also we have to consider. So that's why we are adding 2. So this is whenever we have any um, contiguous subarrays that we want to add up, what we will be doing is we will be using the just we will try to add their lengths. The ultimately all the subarrays will be counted up here. So similarly, when once we move here, we will again do the same r minus l plus 1. Only one number will be added. Again, once we move here, we have to, since the L will be at this position only, okay, and we are moving L only when R is not equal to 0. So we will be adding one subarray, we will be adding two subarray here, and we will be adding one more subarray, 3, which is nothing but we have to, when while moving from left to right, whenever we whatever is the length that we are updating, that length we have to add to our result. That will result in the number of subarrays. So while the time complexity for this algorithm is like big O of n. Okay, so let me show you the code. So here is the code: L equal to 0, R equal to 0, and we are taking as nums of I, and we have to return long long. So result we are considering it as long long 0. Now whenever every time we will be in outer loop, we will be running L equal to R. Okay, and now we have uh, since we are moving only the right pointer, what we are trying to do is we are checking if it is crossing the boundary, and we will be moving right pointer inside this for loop only when it is equal to 0. Not every time we will be moving the right pointer. So what happens is here this will capture the length. Uh, every time it will capture the length and add to the results. The length is equal to nothing but the number of subarrays till that point, taking that element into the consideration, whichever element we are iterating, whichever element R is pointing to, and we will increment the R value. Okay, and this is finally we have to return the rest. So let's run the code. So it is accept. Let's submit it. So yeah, we got accepted. So that's it. Thank you.